Then the last one that I'm going to do as an example for this particular exercise is going to be question 19. So here for question 19, I think in some ways question 19 is easier than question 18. Y equals the square root of 4 minus x squared. You might be thinking, how can that be easier than this one? Well, some of you will have already guessed it. Why it's easier. It's got to be between that function, the x-axis, and the y-axis. And the y-axis. Now, let's do a little analysis of this, because square root signs spook people. If I had written this little function here, x squared plus y squared equals 4, hopefully immediately you guys will see that that is a circle centered on the origin with a radius of 2. Minus 2, 2, minus 2. And that all this is it's just saying to us that we're looking at the top part of that circle. That's what this is all about. It's a semicircle centered on the origin, and I think the only semicircles you get, even in Extension 1 maths, semicircles are always centered on the origin. I'm almost certain of that. I don't recall seeing semicircles centered on any other place. Alright, so we've got a semicircle centered on the origin with a radius of 2. That's what that is. And it wants it from between the x-axis and the y-axis. Is that right? X-axis and the y-axis. Find the area enclosed. I'm just going to quickly nip off screen and check that question. Find the area bounded by the curve, that one, the x-axis and the y-axis, in the first quadrant. Oh, in the first quadrant. All right. Oh, well, this will be easy peasy, won't it? Then we'll just have the area equals the integral of 4 minus x squared to the power of a half, excuse me, with respect to x. And if it's in the first quadrant, then the limits will be from x equals 0 up to x equals 2. So from 0 to 2. Now, it looks quite straightforward, doesn't it? But it's not. The reason why it's not straightforward is that at this stage, we've integrated something that looks somewhat similar to that, but what was in the brackets never had a power of x there. It never did have a power of x. If you look at all the previous exercises in 3.4 and 3.5, when we had those complex functions that we had to integrate, I think it's just 3.5, exercise 3.5, there was never a power of x. It was only x to the power of 1 inside the brackets. So that makes it difficult, doesn't it? Although, does it? That's a circle. This is a quarter of a circle. I don't know how to integrate that at this stage. You don't know how to integrate that. It's integratable. It's in it. You can't integrate it. But we don't know how to at this stage. But it's just a quarter of a circle. And what I do know, I think this goes all the way back to year 7. You just need to have assumed knowledge, like that you've got all these tools in your belt and you just need to be able to whip those tools out when you need them. And at the moment, the area of a circle we know is pi r squared, and we only want, so the area of a quadrant is going to be equal to pi r squared on 4, and we know what the radius is too. The radius is 2. No pun intended, I'm not that clever. So therefore the area of this particular thing, which is equal to, from 0 to 2, of 4 minus x squared to the power of a half dx, what we know for sure is that that's going to be equal to pi times 2 squared on 4, which is equal to pi times 4 on 4. So we know for a fact that that thing will integrate to give us pi. And hopefully you'll see that the bridge between that being able to integrate that and the answer is just something that we haven't looked at, because remember, pi, every answer we've had so far has been a rational number, yet pi is irrational, and we end up with an irrational answer for this particular problem. So there's got to be something quite complex going on there that we don't know about as yet, but you'll get to. Alright, so the answer is pi units squared. There we go.